Okay. For the sake of demonstration, I have taken the WHO test hospital. That is by default, it is present in the during the time of uh, software what you just put in your computer. So whenever you open, you can find WHO test hospital. Okay, so because we need a large data to understand how to do the important data analysis. So I have opened WHO, or I'll go from the beginning. So I'm double clicking the WHONET. So here I'll click the option WHO and open laboratory. Okay, I'll just tell you how to take the clinical report of a particular patient's isolate. So you have to open the data file. I'll open the data file that is already there in this, and I'll go to the view database. Here we have the database for all the patients. So I'll select some patients data. I'll select this and go to edit. So okay, so this is the data what you have entered. So simply what you have to do, you have to click the print option. And before that, you have to configure your report how it should appear. So for that, I think Dr. Malini would have told you have to go to modify clinical reports. So what a reporter header should have. So you have to put your lab name or hospital name. Then you can put other columns also, other rows like the address or something, and the font, all these things you can configure. And data fields, again, it's very important. So what are all the important data fields you want? Definitely, you would like to have the identification number and the patient's name. So that also you can configure whether you want it in the right side or left side. All these things you will complete. For the results, so you will tell about the organism. You would like to have the comment and any other thing what you want to include. All these things you can put, and even the font you can change by the font option. So now you have configured how the report should appear. See, again here one important thing: number of reports per page. Say suppose you give 3 at a time, 3 patients report can be taken in single page, and you can tear and give, but it's always wise enough you put 1, so that it is one report, patient's report will come in 1 page. So that is the right option, correct option, and it will look nice. Okay, so we'll give save. Right, so very simple, you can just click the print. If it is connected to the printer, it will show the printer which is connected to your system. You can just click the print and you can get the report. So I'll convert this report in the form of PDF to show you how the report will appear after the print. So I'll click to PDF option and give print. So it will ask me have to store that the PDF file. So test report, I'm saving it on the desktop. Exit, minimize. Okay, test report. Yes. Okay. So this is the way you get, see all these things you have to configure. You can put it in the center, and the address can be put on the left and right side, what you want, all these things you can enter. So whatever you have configured in your report, that will appear in the report. So this is the one what you will get after you click print. Okay. Suppose you have a letterhead. So you have a own labs letterhead. You can delete all these things during the configuration of the report. You can just put a blank for the header, and you can take the printout in the laboratory letterhead. So that is the way you can take a printout. If you have to configure it in the nice way, you can put it put in a good fonts, whatever you like, the size, everything you can put, and so that you can optimize the report and you can deliver the reports with the help of this option. Okay, so now I am in the WHO test hospital. We'll see the data analysis. Very important aspects of the data analysis I will tell you. Okay, so this is the analysis box. Once you click the data analysis, this is the screen what will appear. So we have to go into it. So when you on the top you can see analysis type. Okay, so click the analysis type. By default, you will get this percentage RIS and test measurement, because this is the one what we do often, and the other options we may not do often. So this one will give you the percentage of resistance, intermediate sensitivity, and also the measurements of the breakpoints and other things. So you have to click this. By default, it will be already clicked, and by default, you will get this. So once you have selected this, you click OK. Return. So you have given now what analysis you want to perform. That will appear in the box. Now I want to analyze the Escherichia coli. So I will click on the left side. You can see organisms. I will click organism. I will go to the Escherichia coli. Double click it. It comes to the analysis box. Okay. So Escherichia coli. Now this is very important, data file. From which data file you want to see this? So you may have monthly data files. You can see it in the different months, or you can combine all the files. Okay, you have the option of combining all the files. So I want to see January, February, and March. I can combine all these three files under a single file that I can select. Okay, so here by default, all the results will be stored in the C folder, but in our hospital, we have created a separate folder in the D, and we transferring all the files there, because what happens in the C program, if OS is corrupted, you will lose all the files. So we normally put all the files in the D folder, and we give the extension to the D. So all our results will be stored in the D file. And the another thing is, you can copy the file and take it to any other system which has the same laboratory configuration, wherein you can analyze the result. It's not mandatory that you have to analyze the result only in the computer where you have entered the results. We can just copy the file, take it to another system with the same laboratory configuration. How another system will have the same laboratory configuration? Very simple. Even laboratory configuration is saved in the form of a file. So what normally we do, we copy the laboratory configuration file into a new system, and we will copy there, so that the laboratory configuration needn't to type again anything. I can just open the laboratory configuration of a file, and I can install that laboratory into the WHONET software. Okay, so I have clicked this file, just double click, and it should transfer here to the right side box. That click OK. So now this important boxes have been selected. So I am going to see the resistance sensitivity pattern of Escherichia coli of a particular month. Okay, so I have given the data file also. So then I'll click the begin analysis. Okay, so this screen will appear. On the top, you can see the table, which gives the number of see the column where antibiotics, you can see the breakpoints of that antibiotic. So this number is very important. Okay, there are totally 86 isolates. 86 isolates. Some antibiotics they have put 85 times. Some antibiotics they have put only 28, some 8. Okay, so this is where the quality control. See, sometimes some common antibiotics that you have to put will be in a less number. It means that the antibiotic is not there in the lab. Antibiotic disk is not in the lab, so the technicians are not using that. So you can very easily find out what is missing in the lab, and you can correct it. Okay. So these quality control and other things can be seen through this. Then it gives the percentage of resistance, intermediate, and sensitive. Okay. Now it is also displayed in the form of graph. Okay. All the microbiologists will like to see the resistant profile for any microorganisms, whereas the clinicians will like to see the susceptibility graph. So all the options are there. So you can see the right right side you have options. So it is clicked as resistant. Okay, so if I want to see the susceptibility graph, I can just click the susceptible that will appear. Okay, the susceptible graph will appear. Then also I can go individually as an individual antibiotics. If I click ampicillin, okay, a graph appears. Okay, the x-axis shows the zone of inhibition in millimeter. Okay, and the y-axis shows the percentage. Okay, percentage of sample which shows this particular diameter, the percentage of isolates which shows that, say here 6 is the minimum number what to enter. We cannot enter 0, 1, 2 and all. 6 is the minimum number you can enter. Normally 6 shows that it is 0. I mean it's completely resistant. Okay, so you can see two red lines. Okay, so the one in the left side, the zone of inhibition diameter, which is less, okay, they are resistant. On the right, it is sensitive. The between the two red lines, it is intermediate sensitivity, right? So you can see a lot of organisms. I mean, lot of the percentages of the organism E. coli shows wild type. Okay, so this graph will tell you how much the wild type E. coli or any selected organisms are there in your isolates. Okay, so you have isolated 86 and many are belonging to the wild type for the ampicillin. Okay, so that too the some will be present in the extreme right side. So there will be a perfect wild type isolate. So this particular graph will tell you. So here again the wild type are more. For this antibiotic again the wild type are more. So you can just follow up the trend. Just follow up the trend. So this graph will help you to follow up the trend for each and every antibiotic separately. How many mutants are there? How many wild type isolates are there for a given bacteria? Right. So once you finish, see now this graph. Suppose I want to use this graph I want to transfer this graph into a PPT or a MS Word. Simply here on the top we have option copy graph. Okay, so you can copy the graph and you can just click copy. The graph will be copied, and then I can take it to a PowerPoint. And just if I click Control V, the graph will be pasted. So whatever graph comes, you can just click the copy graph and you can paste it. Okay, and also you have the option of copy table or print table. So the entire table can be copied or printed, or you can just go to the file and you can click save graph. Okay, and the graph can be saved in any format. Or I can go to the print graph and I can straight away print the graph. Suppose if I have finished now, so I can just, if you want to come out, you have to click continue. Okay, now I am interested in Escherichia coli in the urine sample. I want to see how the antibiotic sensitivity pattern of Escherichia coli only in urine sample. Okay, what I can do here, the right side you can see isolate. So I will click this. Okay, so here lot of options are there. Suppose you want to see location type, location wise. I want to see the pediatric ward, how the antibiotic sensitivity pattern is there for Escherichia coli. Okay, I can select the location type or age category or the department wise I can see. So, but now I am interested in specimen type. So I will click the specimen type. Okay, now the box will open. It will ask what specimen type you want. I'll select the urine. I'll click the urine. It is been selected. Then click OK. Or you can also bring, say you are going to see the entire thing in which you want to exclude certain things, you can click exclude. Okay, by default it will be include urine. Okay, so I'm just clicking this, and so now specimen type urine. Right. So now only from urine sample I want to see about the total isolates, Escherichia coli isolates, or what is the total isolate, and I want to see the sensitivity pattern. So I have selected specimen type urine. Just begin analysis. Okay, now there are totally 58 isolates from the urine. So that's what it tells. Okay, now again it gives the resistant pattern. Okay, so I can also click the susceptible pattern. I can click and find the graph. Okay, so another advantage, you can modify the graph. Say many times the people see the graph is not looking good. It's on the same blue color. Okay, so what we can do, we can give a right click. Just keep the uh, selection arrow on the graph. So right click, then you have a graph control. You can see a box, get graph control. You have a lot of options. Okay, you can go to the 3D gallery. You can click the 3D bars, so it will be converted into 3D bars. Or style. Say the bars looking like a histogram. It looks very clustered. So what I can do, I can just minimize. I can just gaps can be increased so that the bar thickness will be reduced. Okay, now I have reduced the bar, so it looks nice now. Okay, so this I can do. Then lot of things, features are there. So graph title, I can add something. Here it shows susceptible. I want to add something along with susceptible pattern in a particular month. I can add. And the bottom title is antibiotic. That also I can modify. So all these things I can do. So background. Okay, I can change the background. It is white in color. I can change the color, background color. So I want to put a yellow color as the background. So it will be yellow color. Even the fonts can be changed. You can put different colors for the legends, what is there in the graph. So we have a lot of options in the graph control box. You can just work out and find out which one is suitable and which one is good looking for your presentation. You can select. Okay. Right. Okay. Then if I want to come out, I'll click continue. Okay. So, yeah, so along with the specimen type, I want to see the location. So I want to see the outpatient urine sample from the outpatients department. What is the profile? Outpatients mostly will be a community acquired infection. So I am interested to see the outpatient. So I also include that along with the urine sample and then begin analysis. Okay, now it only 15 isolates from the outpatient department from the urine sample. Now I see the resistant pattern of the isolates. Okay, so you have other options which are same. So when I want to come, I can just click continue. Okay. So what are other interesting options? I can take a summary. I can take a summary of the thing. So suppose you want to give the summary to the clinicians, I'll put susceptible. So as a microbiologist, I'm interested in resistant pattern. So in the columns, I'm changing it as resistant for all antibiotics, or you can select few antibiotics. Here another option is given. I can select only those antibiotics which I am interested. I can select, browse, and select the antibiotic which I want to see the resistant susceptibility pattern. Here I am selecting all antibiotics. I am clicking OK. So now I want to see the summary. Yes. So you got the summary, Escherichia coli, 15 isolates. So for the different antibiotics, what is the resistant pattern it has given. Okay. And also the graph for this particular table is here. Okay. So this is the another option you have, important option. for our resistant pattern monitoring. Okay, continue. Okay, another interesting option what I want to give, you can see the resistant profile alone. You can give, say, in the laboratory configuration, you would have given for each bacteria what is the antibiotic you want to see about the resistance. Okay, not all the antibiotics. You want to see some antibiotic or very particular in some antibiotic for which you want to see the resistance. Okay, so you can just change it as the resistance profile. Click OK. Then I'll remove this isolate, the location type. So that okay, we'll find out the second part will give you. So that's the reason why we put the resistance profile. So here it gives, okay, resistance profile for the different. So antibiotics, some are combined, some are separate. Okay. So not much multiple resistant isolates. So I'm happy that we have not got a multiple resistance. By this analysis, I can find. Okay. So that's one way it is good. I feel that isolate doesn't have much multi-resistant. Okay. So continue to come out. So another interesting thing is the scatter plot. Okay. So I'll select a different organism. I'll go to the Staphylococcus for a change. Staphylococcus aureus. I'll go to the blood. Semen type. It's now urine. I go to the blood. I'll x-axis, y-axis I can select. Okay. Okay, so now I am comparing the oxyacillin and the amoxicillin. Okay, so what I see in the right side alone, I am seeing the thing. So this one is sensitive for both this antibiotic. All the bacteria are sensitive for both. So it is a wild type. So all the isolates are wild type for this oxyacillin and amoxicillin. So it's another scatter plot analysis what we can do in terms of this analysis. So another interesting feature we have. Okay. So these are the important aspects that we have in the analysis. So so you can just use the one which is very commonly we require, that is a percentage RIS and measurement, and you can select the specimen and the organism what you want to do. You can select multiple organisms also, say I can so I can just again go to the urine. Organism, I'll select Escherichia coli. Okay. Also, I'll select Pseudomonas. So, two organisms I want to see. Pseudomonas. Okay. So, begin analysis. So, I can see one by one. So, now it shows for the Escherichia coli. So, I put continue. Then it goes to Pseudomonas aeruginosa. So, continuously I can see that for the different organisms. Instead of selecting one by one, I can select everything together and you can see the results for all the bacteria. Okay. So, I am coming out. Then after finishing, you can give exit. Okay. So, this is what in concise about the data analysis.